Hi everyone, and today I'm going to present my work on multimedia search ranking with object recognition, and I'm Wang. And first of all, what is multimedia search ranking? And imagine you are a multimedia search engine user and you want to search for some multimedia documents, and you input a query, but the current search engine rely heavily on the text descriptors. For example, the surrounding text of the multimedia document or the assigned text given by the user. But this often leverage not satisfactory results. So we try to incorporate with visual features for a re-ranking stage to re-rank the multimedia document in the second stage. And in general, multimedia search re-ranking can be categorized into three types. The first type is using an unsupervised approach. We try to learn some clusters based on unsupervised learning and to perform re-ranking. And the second category is to use some kind of graph-based approach. Basically, we do pairwise similar. We treat each image as a node, and we do pairwise comparison between these kind of nodes and perform a second stage ranking. And the third category is what I'm interested in, that is object recognition based multimedia search re-ranking. The idea behind this kind of approach is we try to infer semantics. We try to infer a semantic concept from the image, and based on this kind of semantic concept, we perform a second stage re-ranking. So this kind of concept-based multimedia search re-ranking can be defined as reordering of visual documents based on the information manifested in the initial search result using concept recognition. But this is my structure of the presentation. First, I would like to give a short introduction on concept-based multimedia search re-ranking before 2012. And I will introduce some recent development in deep learning and some applications to use deep learning for concept-based multimedia re-ranking. And the third part, I will introduce my experiment on scalability retrieval. And in the next part, I will try to introduce some available datasets and give the discussion and conclusion. So the first part. So some facts about concept-based multimedia search re-ranking. A lot of work has been done in this area. And in my point of view, this work can be categorized into two groups. The first group try to train a model from the outside data and directly apply it into the images given by the initial ranking list, and to categorize whether it is or not. So the represented work based on nestive is they trained a support vector machine on 39 concepts, and the overall performance gained to 77% with respect to text descriptors. And compared with the state-of-the-art multimedia search ranking framework, their accuracy increased by average precision increased by 31%. And the second stage is to add a filter process and rank this guy, treat internet search engine result as a loosely annotated documents. They first employ unsupervised learning to filter out the unrelated documents. For example, they use k-nearest neighbor approach. And this is followed by a supervised or semi-supervised classifier to perform the second stage ranking. And as we can think from here, that this works is very intuitive and might be very effective in certain topics, but this has a lot of limitations. If we look at the concept space, the previous work has been done. The concept space ranging from 7 to 300. So this is impossible to apply into a real-world multimedia search scenario. And due to maybe for some other reasons, for the less development in the computer vision communities, the learned concept may bring some noise into our re-ranking model. So this is not that effective. So the research gap is that can we try to use deep learning to further expand the capability of concept space and to improve the detection accuracy. If we look at the current development in deep learning for different tasks, and I personally think this 6 category might be further applied to concept-based multimedia search re-ranking. The first one is image classification. We try to use deep learning to classify whether this is a dog or cat. The second one is object detection. We localize and segment objects from the digital images and video keyframes. The third one is scene recognition. For example, we try to recognize whether this is a road or a sky or something like that. And the fourth one is face identification. We try to classify whether the name, the identity of the person. And the last one might be landmark recognition and image capturing. And here, actually some of work has been done in the try to employ deep learning for multimedia search re-ranking. And most of them are using an unsupervised manner as we described before. Basically, they try to, instead of using the SIFT or HOG representation of the images, they try to use the deep representations learned by deep learning and apply unsupervised learning on it. But some of the researchers tried to apply deep learning to learn a category constraint on the images we have or multimedia documents we have to reduce the amount of document. And the third one, try to employ RCN, and basically RCN is an object detection algorithm. And try to demonstrate a re-ranking stage to refine the initial ranking result by using a fusion of keywords and dissected concepts. And based on this idea, they built a search engine named Goose. And after that, due to the limited application of concept-based multimedia search re-ranking, I myself conducted an experiment on celebrity re-ranking. So basically, celebrity re-ranking, celebrity retrieval is a very common using scenario in our case. We try to search, sometimes when we type into the search engine, we want to search for Trump. Maybe the result is Hillary or something like that. So it is not very satisfactory. So we refine the initial ranking result by integrate a deep convolutional neural network model pre-trained on Microsoft Celebrity 1 million dataset. And the procedure is like this. We first select some celebrities as candidate list, and we search from Google, Bing, and Yahoo to get the initial ranking result. And we estimate the probability using the pre-trained deep learning model. And we give the final score, and we evaluate with NDCG. And you may be wondering that how can we get the score? Basically, if we treat each initial ranking result as some sort of, if the image is ranked in the top position, then we think it is more relevant to the query user input. So we first assign an initial score on the image M, and this is affected by a decrease factor we define here named lambda, and the I here is represented for the ranking position of the image. If the image is ranked in the maybe in the first position, then the initial score gonna be 100, and it decreased by maybe 2.2 or something like that. And we obtain the final score by multiply the initial ranking score with the inner product of the probability given by our ranking model. And we have a binary factor here to determine whether this image is related to the user's query. If it is unrelated, then we set the binary score to 1. Then the final score gonna be 0, and it will be ranked in the last position. And we conduct this experiment using Google, Bing, Yahoo, and we refine the ranking list indicated here. But you can see a lot of question mark here because there is something wrong with my GPU server. I need to, but the result can be in my final version of paper. But according to my observation, the ranking result is much more better than before. And in the last part, I would like to survey some available datasets for deep learning, because deep learning rely heavily on the datasets. So we have ImageNet for image classification and object detection. We have COCO dataset for multiple object detection. We have Places and Places2 datasets and Sun datasets for scenes detection. We have labeled face in the wild, which can be shortly named LFW, and Megaface and Microsoft Celebrity 1 million dataset to perform face identification. And we have YFCC 100M dataset for more general purpose. And we also have some smaller dataset for more specific tasks. For example, the Oxford flower dataset try to classify whether a flower is from a certain class. And some discussion. We think that concept space, by leveraging deep learning, the concept space has been greatly expanded. And intuitively, and this kind of concept-based multimedia search tree ranking is very intuitive and efficient and will bring us high accuracy. And these models can be even outperformed than human beings. And currently, concept-based multimedia search tree ranking might be more suitable for a specific task in multimedia search tree ranking. And we have a potential problem, that is, I think this can be defined as concept granularity. That is, we don't know whether this concept is belong to one search list or something else. For example, if when we search for a car type, maybe we are interested in the more specific car type instead of whether it is a car or not. And we think that intent estimation based on user profile and keywords and context might be helpful to map into a related pre-trained model. And some takeaway. I think concept-based multimedia search tree ranking not performed very well before 2012. And deep learning-based concept detection provide a small probability on this ranking process. And we conducted an experiment on celebrity retrieval, and we surveyed some available datasets for deep learning. And in the future, I think intent-aware concept-based multimedia search tree ranking might be very useful. That's it. Thanks.